Hi there, today we're going to be making a little simple snake game on the Raspberry Pi using the Sense Hat and its 8x8 pixel LED screen as well as the joystick. I'm going to be coding this on the online emulator from Trinket, but you can be coding this straight onto the Raspberry Pi. I'm just doing this to make it easy to record. I will show at the end how it looks on the actual Raspberry Pi. But to start with, let's just get right into it. So we're going to import what we need. We're going to need time and random, and then we're also going to need the actual sense hat, which we do by saying from sense hat import sense hat, and then we're going to make an instance of it by saying this, and this just gives us an instance of the sense hat to let us manipulate the screen and get the input from the joystick and do everything that we'll need to do. I'm also just going to define our colors, so our red for our apple, our white for our snake, and our clear color, which I'm just going to make black. You can make these whatever you want, of course. These are just kind of the defaults for snake. And then to store all the coordinates of the snake, I'm going to make an array called trail, and in this we're going to have essentially coordinates or vectors for each part of the snake's body. So to start with, we're only going to have one little part. I'm just going to set it to be 3, 3, which is kind of in the center. Then we also want a vector for the direction that the snake is moving in. So by default this will be moving right by 1 on the X and 0 on the Y. And then we also want an integer to store the current length of the snake, which I'm just going to set to 1 by default. Then we want another vector for the apple's current position, which will start in a random position between 0 and 7. So this will spawn the apple in any of the positions on the screen. And then we also just want to store our pixels as a 64 long array of our clear color, and we'll manipulate this later on to render to it, and we'll see more of how that works later. So now we want a game loop, so we're just going to say while true, and at the end we'll do time.sleep 0.15. That's just a number that I found worked the best, but you can play around with that depending on if you want it faster or slower. At the start of each loop, we want to clear the screen by just initializing the pixels variable to be all clear. And we can see how the rendering works by rendering the apple to start with. So I'm just going to say, so to do that, I'm going to write this. I'll explain it afterwards. It might look a bit weird, but I'll explain it once I've written it out. So basically, because we're storing the apple's position as a 2D coordinate, but we're storing our pixels in a one-dimensional array, we need to convert those 2D coordinates into a one-dimensional coordinate. And the formula for doing that is y times row size plus x. So that's essentially what we're doing here. We're getting the y coordinate of apple pos, which is, so 1 is the second element, which is our y coordinate. We're multiplying it by the row size, which is 8. And then we're adding the x, which is the first element in the apple position coordinate, which is another random value. And then we're setting that to be red. So to be able to see how that works, we want to set the actual sense hat pixels to be that array. So if we run this now, we can see every time we run it, the apple will be set in a random position, and it's being rendered as a red pixel at one of the LED lights. So that's working all good. So now we want to start working on the actual snake itself. So to render that, because it's going to have multiple positions, we want to loop through all of them. So I'm just going to say v. Actually, I'll say pos in trail. And so for each one, we want to do that same conversion. So we want to say pos 1 to get the y, times by 8, and then plus pos 0 to get the x. And we want to set that equal to y. So if we render this, we should see that that's a white pixel in the center because we set it at 3, 3. So 0, 1, 2, 3, 0, 1, 2, 3. And so it's looping through all those elements, but there's only one. And then later on when we have more elements, you'll see that they should all be rendered in their correct positions. So let's start moving the snake around. So what I'm going to do is we're going to define a method called set direction, and it's going to take in an integer d, and we're going to be able to convert a number. So I'm gonna set these numbers to be equal to each direction. So we're gonna have 0 equals up, 1 equals right, 2 equals down, and 3 equals left. So we can just have that comment there to refer back to. So this method will take in one of these numbers and return the corresponding vector. So we'll say if d equals 0, which is up, we want to say direction equals 0, -1. So that's moving 0 on the x-axis and -1 on the y-axis. Then we're going to say else if d equals 1, which is right, we want to set it to be moving 1 on the x-axis and 0 on the y. Else if d equals 2, which is down, we want it to be 0 on the x-axis and 1 on the y. And then else if it's 3, which is left, we want to be -1 on the x and 0 on the y. So that's just a little handy little function that we can use to set the snake's direction. But we'll also need to make a global reference to the direction so that we can modify this global variable in here. So now we want to start actually using the joystick of the sense hat to move it. So the way we do that is we say for event in sense.stick.get events, and this will give us the current this will give us the current event that's being actioned on the joystick. And there's 3 different types of events. There's pressed, held, and released, I believe, but we only care about pressed because we only want to respond when the joystick is pressed in a new direction. So we want to check that. So you have to make sure that that string is exactly how I've typed it. And now we want to check the direction of it. So say if direction is equal to up, again make sure that string is exactly how I've typed it. So if it's up, we want to set direction using that method that we just made. Set direction 0 because 0 equals up. Else if event.direction equals right, set direction to 1, which we defined as being right. Else if event.direction equals down, we want to set direction to 2. And then if it is left, we want to set it to 3. So now this will be moving the snake, but we actually, before we do that, we're going to have to so the way that we move the snake around is by each loop of this game loop, we want to add the snake's new coordinate to the start of the array and remove the last element in the array. This will give the illusion that the snake is moving, and also keep it to the correct length. So you'll see how that works in action, but to do that first we need to insert that first element in the start. So we say trail.insert 0, so that's inserting into index 0, which is 0, which is the first element, and then we want to make our new coordinate. So the way we're going to do this is we're going to get the first element, the first coordinate of trail, which we just do by 0, and then we want to get the x coordinate of that, which is stored in the first index, which is 0. And then to this we want to add the x coordinate of the vector. So again, this is getting the first element of the snake. It's getting its x coordinate by doing the second 0 index, and then adding the x coordinate of our vector for direction. Hopefully that makes sense. I know it's a bit confusing, but hopefully that makes sense. And then we also want to do the y coordinate. So we're going to get the first coordinate, and we're going to get the y component, and then we're going to add the y component of our direction vector. Now, what we want to do next is we want to do all our special cases for checking the snake's position. So what we first need to do is check if we're currently over the apple. So if our first coordinate, which is essentially the head of the snake, you can think of it as, If that's at the apple's position, that means that we've eaten the apple. So what we want to do is respawn the apple in a new random position. But we want to make sure also that the apple isn't spawned in a location that the snake is currently occupying. So the way that we're going to do that is we're going to set it to an empty coordinate. And then we're going to say while apple pos is equal to that empty coordinate, we want to set it to a new random coordinate by doing what we did up the top when we first defined it. But what we want to now check if that is in the snake. So we want to say if apple pos is in trail, then we want to set it back to the empty coordinate. And so if this happens, it will come back to the start of this while loop and set it to a new random position. And this will make sure it will keep looping until the apple is spawned in a random location that the snake is not currently occupying. Then, once we've eaten the apple, we want to add 1 to the length, so the snake gets longer each time it eats an apple. Now we want to say else, while the length of the snake is greater than the length it's supposed to be, we want to say trail.pop. What pop does is it removes the last element of the array. This is what I was talking about before. We're inserting something to the start of the array and removing something at the end. And we're doing it in this while loop to make sure that it keeps removing these elements until the snake is at the length that it's supposed to be. And this will give it the illusion that it's moving as well as keeping it at the correct length. While we're here, we also just want to add in here, we just want to say if trail 0, which is the head coordinate of the snake, if that is in trail 1 colon, we want to set the length back to 1. What this is doing is checking, I'll add a little comment, reset length if snake runs into itself. This is an important mechanic of the game, and we're making sure that if the head of the snake collides with any other coordinate of the snake, which is what this is doing, reset the length to 1. Now, the last thing is in here, we want to just make sure that if the snake goes off the screen, it'll come back at the other side. So if it goes off the left, it'll come back on the right. If it goes off the bottom, it'll come back from the top. And if it goes off the top, it'll come back from the bottom and all that. So the way we're going to do that is we're going to say if trail 0 and then 0, so this is getting the x coordinate of our head. If that's less than 0, so if it's gone off the left side, then we want to set it to be 7, which is this last coordinate. We want to do the same for the head's y coordinate, so if head 1 is less than 0, set it to be 7. Now we want to check if it goes the other way, so if the x coordinate is greater than 7, set it to be 0, and if the y coordinate of the head is greater than 7, set that to be 0. And this should be everything, I think, so let's run it and see how it goes. So we'll press run, and you'll see here, I'm just going to use the arrow keys for the joystick. It'll move around and eat the apple, and when it eats the apple it increases by 1, so we're up to 4 now, we're up to 5, eat the apple. And then we can also check if I run into myself there and reset the length back to 1. So this is the fully functioning snake game. We've got everything. We've got eating the apple and respawning it, we've got running into ourselves, we've got moving off the side of the screen and respawning on the other side. So now let's look at how this looks on the actual Raspberry Pi.